Good morning everyone. Myself Indranil Mondal, Assistant Professor in Mechanical Engineering Department. Today I am going to present an important topic, engine transmission system related to automobile engineering. Let's start the session. These are the main contents: layout of engine transmission system, functions of transmission system, various components of transmission systems, and engine components, that are cylinder block, crankcase, cylinder head, oil sump or oil pair, and cylinder liners. Let's discuss one by one. This is a schematic diagram of transmission system of an automobile. The transmission system consists of a clutch, a gearbox giving 4, 5 or even 6 different ratios of torque output to torque input, a propeller shaft to transmit the torque output from the gearbox to the rear axle, and a differential gear to distribute the final torque equally between the driving wheels. Other components are flywheel, frame. What are the main functions of engine transmission system? The functions of a transmission systems are to disconnect the engine from the road wheels when desired, to connect the engine to the driving wheels without shock, to vary the leverage between the engine and the driving wheels, to reduce the engine speed permanently in a fixed ratio, to turn the drive through a right angle, to make provision for the flexing of the road springs, which causes a relative movement between the engine and the driving wheels, to make provision for the flexing of the road springs, which causes a relative movement between the engine and the driving wheels. These are the main functions of engine transmission system. What are the various components of engine transmission system? Engine, clutch, gearbox, universal joints, differential wheels, and axles. Let us discuss one by one. Engine. A wide range of engines has been used experimentally and in automotive production. Classification of engines. Based on type of ignition, engines are classified as spark ignition engine, that is petrol fueled, compression ignition engine as diesel fueled. Based on cycle of operation, engines are classified as Otto cycle engine, diesel cycle engine, and dual cycle engine. Based on engine cycle per stroke, engines are classified as 4-stroke engine and 2-stroke engine. Based on fuel used, engines are classified as petrol engine, diesel engine, and gas engine. Based on method of cooling, engines are classified as air-cooled engine and water-cooled engine. Based on number of cylinders, engines are classified as single-cylinder engine, 2-cylinder engine, 3-cylinder engine, 4-cylinder engine, 6-cylinder engine, 8-cylinder engine, 12-cylinder engine, and 16-cylinder engine. Based on arrangement of cylinders, engines are classified as horizontal engine, vertical engine, radial engine, V engine, and opposite cylinder engine. These are the basic classification of engines. Let us discuss what are the functions of engine components. Clutch. Its purpose is to enable the driver to disconnect the drive from the road wheels instantaneously and to engage drive from the engine to the road wheels gradually while moving the vehicle from rest. What is the function of gearbox? The gearbox or the transmission provides the necessary leverage variation between the engine and road wheels. Universal joints provide for the relative movement between the engine and the driving wheels due to flexing of road springs. Differential. While taking turns, the driving wheels must at different speeds. This is done with the help of differential. Wheels. A wheel is a device that allows heavy objects to be moved easily through rotating on an axle through its center, facilitating movement or transportation while supporting a load or mass or performing labor in machine. What are the functions of axles? An axle is a central shaft for a rotating wheel or gear. These are the main functions of clutch, gearbox, universal joint, differential, wheels and axles. This is a schematic diagram of engine and engine components. This is a crankshaft, this is flywheel, this is piston, this is a cylinder where the piston moves, cylinder head, combustion space, gasket, piston ring, gudgeon pin, water jacket, connecting rod, crank pin, flywheel, balance weight, main bearing and oil sump. This is another schematic diagram of engine components. Let us discuss what are the major components. Cylinder block, crankcase, cylinder head, oil sump or oil pair, cylinder liners, piston, piston rings, connecting rod, crankshaft, flywheel, camshaft, spark plug or fuel injector, valves and valve mechanism. In this video lecture, I will discuss cylinder block, crankcase, cylinder head, oil sump or oil pair and cylinder liners. In my next video, I will discuss piston, piston rings, connecting rod, crankshaft, flywheel, camshaft, spark plug, valves and valve mechanisms. Cylinder block. The basic framework of the engine is formed by the cylinder block. It houses the engine cylinders which serve as bearings and guides for the pistons reciprocating in them. Around the cylinders there are passages for the circulation of coolant. At the top of the cylinders, these passages end either just below the block's machined joint face, which is then called closed deck, or at the level of the joint face, which is then known as open deck. In case of a closed deck, circulation of the coolant is provided by vertical drilled holes meeting with the corresponding holes in the cylinder head. This is preferred over the open deck on accounts of its greater reliability to provide leak-proof joint, although the latter is relatively easier to produce. Cylinder block also carries lubrication oil to various components through drilled passages called oil galleries. During manufacture, the oil holes are drilled and rarely cast. In case of a carved passage, intersecting drilled holes are used. The ends of the drilled holes are sealed by plugs. At the lower end, crankcase is cast integral with the block. The function of the crankcase is to provide support for the main journals and bearings of the crankshaft, rigidly maintaining the alignment of their axis of rotation under various engine loads. Previously, crankcase was cast separately and attached to the block, but now the integral or the monoblock construction is preferred. Crankcase is shaped simply like a box having no bottom, its roof being formed by the lower deck of the cylinder block. The bottom of the crankcase walls is flanged to straighten the casting and to provide a machined joint face for the sump to be attached. Crankshaft is supported in the crankcase through a number of bearings called main bearings. The construction of the crankcase has to be such as to provide very high rigidity because it must provide reactions for the heavy forces set up due to gas pressures in the cylinders. This figure depicts the bottom view of cylinder block and crankcase showing main bearing housing to support the crankshaft. At the top of the cylinder block is attached the cylinder head. Besides, other parts like timing gear, water pump, ignition distributor, flywheel, fuel pump, etc. are also attached to it. Mating surfaces of the block are carefully machined to provide perfect sealing surface for attaching these parts. The function of the camshaft is to face the opening and closing of the inlet and the exhaust valves for each cylinder. Camshaft may be mounted in the cylinder block or head or even above the cylinder head. It is always placed parallel to the crankshaft. When in the cylinder block, it is mounted to one side of the cylinders, either low down just above the crankshaft or high slightly below the cylinder head. The camshaft is supported in usually 3 bearings force feet in the cylinder block bore. Main bearing boards and camshaft bearing boards are aligned board to allow these shafts to rotate freely. The center liners of the all cylinders must be at exact right angle to the crankshaft center line to avoid side stresses on pistons, connecting rods and cylinders, thus ensuring free movement of pistons. Likewise, valve lifter boards are also machined at right angle to the camshaft bearing boards. Cylinders in the block are machined and honed to a very accurate finish for good lubrication and proper ring seating. Cylinder walls are finished to 1 micron finish with a fine rotating horn. An intersecting visible crosshatch scratch pattern is produced by the horn form. The cylinder block is basically a casting product. Both monoblock and individual cylinder casting techniques have been tried, but the former has proved more useful due to the following reasons and is therefore being employed universally. The problem of having good water sealed joints is reduced because of reduction in their quantity. More positive water circulation is achieved. The manufacturing operations like machining the joint faces, cylinder boring, etc. are simplified. Closer cylinder spacing is achieved, thus reducing engine size. An assembly far rigid than in the individual cylinder construction is achieved, thus reducing tendency to vibrate. The individual cylinder construction, on the other hand, has its own advantages. Replacement of a single cylinder casting is less costly than replacing a multi-cylinder casting. Because of lesser weight of individual cylinders, handling during repairs is easy. In case of air-cooled cylinders having fins around them to increase the heat transfer area, it is easier to adopt individual cylinder construction than to cast en bloc. The materials generally used for cylinder block are grey cast iron and aluminium alloys. Grey cast iron is so called because of its grey appearance when fractured. In this, the carbon is present as flakes of graphite, which makes it more wear and corrosion resistant, apart from its better machinability. The aluminium alloys used for cylinder block are the aluminium silicon types, which have good casting properties, are corrosion resistant and retain their strength at moderate temperatures encountered in the engine block. Out of these two materials, cast iron is the one which is mainly used because of some advantages. What are those advantages? It is a good foundry material. It has high machinability. It does not wrap under the high temperatures and pressures developed in the cylinders. Due to its slightly porous nature, it retains better the lubricating oil film. It does not wear too much. It has sound damping properties. It has a low value of coefficient of thermal expansion. It is relatively cheap. Aluminium alloys have been used as alternative cylinder block material, chiefly owing to their lightness. The density of aluminium is about 1/3 that of cast iron. However, considering the lesser strength of aluminium, which necessitates the use of thicker sections to carry same load, the saving in weight in case of aluminium alloys is only about 50% compared to cast iron. Besides this, aluminium has a higher thermal conductivity than cast iron. This results in cooler engine running, thereby making it possible to use higher compression ratios. However, it has the disadvantages of more wear, to obviate which cast iron liners have to be used. Besides this, the threads in aluminium are damaged easily in case of any mishandling. Further, since it cannot stand high temperatures, unlike cast iron, there are more chances of damage occurring in case of any loss of coolant. Aluminium alloy cylinder blocks with chromium plated cylinder bores have also been used to obtain lightweight and also less wearing surface. The grey cast iron for the cylinder block usually has the composition 3.5% carbon, 2.5% silicon and 0.65% manganese. Carbon serves to provide graphite which improves lubrication. Silicon provides wear resistance by forming paralitic structure, while manganese increases the strength and toughness. A typical aluminium alloy for cylinder block contains 11% silicon, 0.5% manganese and 0.4% magnesium. Silicon reduces expansion and increases strength and wear resistance, while manganese and magnesium improves strength of aluminium structure. Cylinder blocks for diesel engines are similar in general to petrol engines, except that the former are heavier in construction. The increased strength and rigidity are required on account of much higher combustion pressures produced in diesel engines. This causes greater loads on cylinders, crankshafts, main bearing supports and caps, resulting in their heavier construction. These are all about crankshaft and crankcase. What are the main advantages of monoblock? I have already told. No water leakage, more rigid size is reduced, easy water circulation, and advantages of individual block are easy for repairing and less replacement cost. This cylinder block or monoblock. I have already told about crankcase. This is the base of the engine. This supports the crankshaft and camshaft. Top half of the crankcase is the integral part of the cylinder block. Bottom half of the crankcase, oil pan, pressed steel or aluminium, and material for crankcase are ferrous alloy or semi-steel. This is all about crankcase. Let's discuss cylinder head. It is attached to the top surface of the cylinder block called block deck by means of studs fixed to the block. The gaskets are used to provide a tight leak-proof joint at the interface of the head and the block. The cylinder head forms a combustion chamber above each cylinder. It also contains valve guides, valve seats, ports, coolant jackets and threaded holes for spark plugs or injections. Besides, there are other threaded holes for attaching various components and a number of unthreaded holes for attaching the head to the block. There are also some machined surfaces for leak-proof joints. On overhead camshaft engines, the provisions for mounting the camshaft and related parts also exists. Depending upon the valve and port layout, the cylinder head may be classified as loop type cylinder head, offset cross flow type cylinder head and inline cross flow type cylinder head. In the loop flow type cylinder head, the inlet and the exhaust manifolds are on the same sides, which facilitates preheating of the intake air. When, however, with the same valve arrangement, the inlet and the exhaust manifolds are placed on different sides of the cylinder head, it is called as offset cross flow type cylinder head. This type gives lower exhaust valve temperatures. In the inline cross flow type cylinder head, the valves are positioned transversely and usually inclined to each other, while the inlet and the exhaust manifolds are on different sides of the cylinder head. This arrangement gives better performance but is costlier. The head is almost universally cast in block, even for individual cylinder constructions for the cylinder block. The cylinder heads cast integral with cylinder blocks have also been produced in very few cases, and that too in racing engines, which obviates the necessity of a gas tight joint. But these advantages of the integral construction is not very important because use of gaskets gives a reasonably good gas tight joint. Further, the detachable head types have many other advantages over the integral construction. From production point of view, the cylinder block casting with open bore for the detachable type head is much more simplified. Operations like decarburizing and valve grinding are simplified. The compression ratio can be changed slightly by changing the thickness of the gasket used between the block and the head. The materials that are generally used for cylinder heads are cast iron and aluminum alloy. Apart from weight reduction, more uniform temperature is maintained in case of aluminum cylinder heads because of greater thermal conductivity of the aluminum alloy. Quite often, aluminum alloy head is also used along with cast iron cylinder block and crankcase. Grey cast iron for cylinder head is the same as that used for the cylinder block, but aluminum alloys are usually different. A typical one containing 3% copper, 5% silicon and 0.5% manganese in a matrix of aluminum. Copper increases the hardness and strength of aluminum with time on account of age hardening. However, it decreases the corrosion resistance. An alternative alloy commonly used consists of 4.5% silicon, 0.5% manganese and 0.5% magnesium in aluminum matrix. However, for certain heavy-duty engines such as in racing cars where the cool running of the engines is a major consideration, the use of copper alloys as cylinder head material has achieved much success. The thermal conductivity of these copper alloys is approximately twice that of aluminum and 6 times that of cast iron. Because of this, engine tends to run cooler and consequently higher compression ratios can be employed without occurrence of detonation. However, these are not useful for ordinary engines because then the engine is overcooled, decreasing thereby its thermal efficiency and increasing fuel consumption. This is a schematic diagram of cylinder head, head gasket and engine block. Let us discuss oil sump or oil pair. This is a schematic diagram of oil pan or sump that is fitted at the top of the crankcase by using gasket and contains lubricating oil. Oil pan or sump forms the bottom half of the crankcase. It is attached to the crankcase through set screws and with a gasket to make the joint leak proof. Its functions are to store the oil for the engine lubricating system, to collect the return oil draining from the main bearings or from the cylinder walls, to serve as a container in which any impurities or foreign matter such as liquid fuel, condensed water, blow-by gases, sludge, metal particles etc. can settle down, to enable the hot churned off lubricating oil to settle for a while before being circulated, to provide for cooling of the hot oil in the sump by transfer of heat to the outsider airstream. The sump has a shallow downwards slope at one end and which merges with deep narrow reservoir at the other end. This is done to ensure that under all conditions of vehicle running there will be oil in the reservoir where oil pump is mounted. Inside the sump, baffles are usually provided to reduce oil surging during running of the automobile. At the bottom of the oil sump, a drain plug is provided to drain out the dirty oil at the time of oil replacement. Generally, the sump is made of pressed steel sheet since it is not expected to have much rigidity. However, in some cases, sump of aluminum alloy casting is used, which has adequate stiffness and rigidity. This also provides better oil cooling on account of its higher thermal conductivity. Moreover, with such a sump, particularly when provided with outside ribs, resonant vibration noise is avoided. However, cast sump cannot withstand shocks which may cause cracks. On the other hand, pressed steel sheet sump in such a situation may be dented but will not crack. This is baffle plate, this crankcase gasket, this drain plug and this is oil pan or sump. This is all about oil sump or oil pair. Let's discuss cylinder liners. Inside the cylinder, piston constantly reciprocates, causes wear replacing cylinder block costly. Cylinder liners placed inside the cylinder replaced when worn out. The problem of cylinder wear in the engines is a very acute on ones, especially when cylinder block is made from aluminum alloy. The solution to this has been found in the use of cylinder liners, which can be replaced when these are worn out. Liners are also used to restore to its original size a cylinder block which has been rebored beyond allowable limits. They are made in the form of barrels from specially alloy iron containing silicon, manganese, nickel and chromium. These are cast centrifugally. The liners may be further hardened by nitriding or chromium plating. For nitriding, liners are exposed to ammonia vapor at about 500 degrees Celsius and then quenched. Chromium plating improves their resistance to wear and corrosion. Aluminum alloy liners with chromium plating on the inside have also been used, especially in combination with aluminum cylinder blocks. The use of aluminum alloy results in increased thermal efficiency due to better heat conduction. Further, as the pistons used are invariably of aluminum alloy, the relative thermal expansion between the liner and the piston does not take place, due to which larger cold clearance is not needed. The cylinder liners are of two types, the dry and wet type. Let us discuss one by one. Dry liners. This is a schematic diagram of dry liners. This type of liner is made in the shape of a barrel flange at the top, which keeps it into the piston. The entire outer surface bears against the cylinder block casting and hence has to be machined very accurately both from the inside and the outside. It is put in position by shrinking the liner. This introduces some stresses due to shrinkage and hence the linear bore has to be machined accurately again after the liner has been put into the cylinder casting. Too loose a liner will result in poor heat dissipation because of absence of a good contact with the cylinder block. This will result in higher operating temperatures. If the lubrication is also deficient, it may cause scuffing. Too tight a liner is even worse than the too loose case. It produces distortion of cylinder block, liner cracking, hot spots and scuffing. Even if a correct liner is fitted in a cylinder block which itself is badly distorted, it will result in poor sealing action of rings if the liner is thin, because then it will also tend to adopt the shape of the distorted block in which it is fitted. Even if the liner is thick enough to resist change of shape, there will be some hot spots which will tend to scuffing on the inner surface of the liner. This is all about dry liner. This is a schematic diagram of wet liner, cylinder block, wet liner and packing rings. This type of liner is in direct contact with cooling water on the outside and hence the entire outer surface does not require very accurate machining, but the watertight joints have to be provided. This is done as shown in this figure. At the top, the liner is provided with a flange which fits into the groove in the cylinder block. At the bottom, either the block or the liner is provided with grooves, generally 3 in number. The middle groove is left empty and in the top and bottom ones are inserted packing rings made of synthetic rubber. Arrangements for drainage are provided from the middle groove for any water that may leak enough through the upper ring. However, the number of grooves will vary depending upon the design. Wet liners are sometimes coated with aluminum on the outside, which makes them corrosion resistant. The main troubles experienced with a wet type liner are breaking of flange, scuffing near scaling ring area, and etc. Now let us discuss comparison of dry and wet liners. Dry type liners may be provided either in the original design or even afterwards, whereas the wet type have to be included in the original cylinder design. A leak-proof joint between the cylinder casting and the liner has to be provided in case of wet type, whereas there is no such requirement in the case of dry liners. A cylinder block with dry liners is generally more robust than a block with wet liners. In case of a cylinder block with symmetric adjacent cylinder boards, that is without any coolant passage between the adjacent boards for reducing the overall cylinder length, only dry liners can be used. In case of wet liners, the casing of cylinder block is very much simplified. Better cylinder cooling is ensured in the case of wet liners because the coolant is in direct contact with the liner in this case. Besides, better outside surface finish and more uniform wall thickness of the wet liners improve both the heat conduction and the uniformity of cylinder cooling. Dry type cannot be finished finally before they are fitted to the cylinder block because of the shrinkage stresses produced, whereas wet type can be finished before fitting. For perfect contact between the liner and the block casting in case of dry liners, very accurate machining of both the block and the outer liner surfaces is required, whereas no such necessity is there for wet liners. This is the comparison of dry and wet liners. From this video lecture, you will get knowledge about cylinder block, crankcase, cylinder head, oil sump or oil pair, and cylinder liners. In my next video, I will discuss about other engine components. If you want to get more videos, please like, share and subscribe my channel. Thank you.